This question says how much elastic potential energy is stored in a staple gun if it has a spring constant of 51 newtons per meter. At rest, the length is 0.115 and the length ends up at 0.150. So we initially have a spring that has a distance of 0.115. We then put some sort of force on it to stretch that spring to a distance of 0.150. So really, that gives us some information that we're going to need to calculate the amount of elastic potential that is stored. So really, we're looking for the potential energy that's elastic. We know the formula for potential energy elastic is equal to 1/2 K x squared. We have our K value, which is expressed in newtons per meter. So we have 51 newtons per meter. We also have our X value, although a lot of people will say, they'll try, well, which one's the X value? Remember, the X value is the change in length of the spring, or the change from the equilibrium position. So if it started at this length and ended at this length, what this X value actually represents would be 0.150 minus 0.115, or 0.035 meters. Alright, so now that we have our X value and our K value, we can solve for the potential energy. We can say PE is equal to 1/2 K x squared. So we go to our calculator and we say 0.5 times 51 times 0.035 squared. Oops. 0.5 times 51 times 0.035 squared, and we get a pretty small value. The amount of energy stored in the spring is about 0.0312 joules. So it's actually a pretty small value.